Alright, what's up guys? In this video we're going to pick up some calculus here. It's going to be another integration practice video. It's going to be example number 35 of the integration practice series. So we're asked to evaluate the integral ln squared of x over x to the fourth dx. So we obviously start by applying integration by parts, and we know we're going to have to apply integration by parts twice because once we apply it once, it's just going to drop the power of the ln of x. So we'll apply integration by parts. Formula for that's the integral of u dv is equal to uv minus the integral of v du. We need a u and we need a dv. So the best selection for u here would obviously just be ln squared of x, because remember, to integrate ln squared of x, we'll have to apply integration by parts twice. So that would not be a wise selection for dv. So we'll let u equal ln squared of x, which is a lot easier to differentiate than it is to integrate. And then dv will be 1 over x to the fourth dx. And then we just kind of go through the whole process. So du here, we differentiate ln squared of x. Well, if we use the chain rule for powers, that'll be 2 ln of x all over x. Don't forget to multiply it by dx. And then to get v, we'll integrate dv. So that's the antiderivative of 1 over x to the fourth dx. And that's negative 1 over 3x to the positive third. Then we basically follow the formula. I'm going to bring the negative to the side, so this would be negative ln squared of x all over 3x cubed. Two minuses will change to a plus. I'm going to pull out a 2/3, and then we're going to integrate ln of x all over x to the fourth. So we're going to have to apply integration by parts a second time, pretty much how I mentioned when we first started. So again, we need to do it one more time, integration by parts. And this will happen with some integrals, so just be aware of that. If you run into a situation where you have to do it multiple times, doesn't necessarily mean you did anything wrong, just certain integrals may require the technique multiple times. So again, we're not going to deviate from the selections that we had at the beginning. We're going to pretty much stick to the same selections because we know that integrate ln of x requires integration by parts, so that would not be a wise selection for dv. So we'll get 1 over x dx, and again we're just going to integrate 1 over x to the fourth, which gives me negative 1 over 3 x cubed. Alright, so 2 over third, I don't want to forget that was out there, so I'm going to put it out there. So again, I'm going to bring the negative to the side, so we'll have negative ln of x over 3x to the third. And again, two negatives are going to give me a positive. I'm going to pull out a 1/3, and then I'm going to be integrating 1 over x to the positive fourth with respect to x. So we already know that 1 over x to the positive fourth, the antiderivative of that is negative 1 over 3x to the positive third. So we know that we would integrate that. Now we do have a positive 1/3 on the outside here. So we know that if we were to go back and do everything, we'll have our 2 over 3 on the outside. This would be negative ln of x all over 3x cubed. And then this would be minus 1 over 9x to the positive third. That's what we get when we do the second integration by parts. Now we got to put them both together. So if we put them both together, we'll have negative ln squared of x over 3x to the third. And then this would be plus 2 over 3. And then we'll have negative ln of x over 3x to the third. And this would be minus 1 over 9 x to the positive third plus c. We're going to clean it up a little bit and write down our final answer. So let me do that. So let's take care of, I'm going to expand out the inside. So we got positive 2 over third, or 2 over 3, excuse me, negative ln of x over 3x to the third minus 1 over 9x to the third. So I'm going to expand this out. And if I do that, I'll get negative 2 ln of x over 9x to the third. And then this would be minus 2 over 27 x to the third if I expand out the inside there. And then for our final answer, we can kind of combine everything and write everything down. So whereas to integrate ln squared of x over x to the fourth with respect to x, so our answer to this would be negative ln squared of x over 3x to the third minus 2 ln of x over 9x to the third minus 2 over 27 x to the third, and then add a plus c. And that would be the solution. So again, all I did was kind of clean up the inside a little bit by expanding everything out. So that's your answer. All right, so let me know if you have any questions about how I arrived at my solution. We can talk about it, but that's going to be it. I'll see y'all next time.